This is BTEC Engineering, Unit 7, Section A17 on page 33 of the Section A examples booklet. As usual, this is video and not a lesson, so please pause to make notes. You will need those notes when working through your assessment. So as we've done in the last few sections, we need to find the first and second derivative of a function. Now in this case, s equals 2.1 ln t. Now when we differentiate ln t, it goes to 1 over t. So when we differentiate this function, ds by the t, we've got the 2.1 at the front, so it becomes 2.1 over t. Then we need the second derivative, so we need to differentiate again. Now we have to rewrite this in a different form to be able to differentiate it. So basically 2.1 over t is the same as 2.1 to the power, times t to the power of minus 1. So that is, we're applying the law of indices there. So divided by t is the same as times in by t to the power of minus 1. Then we need to differentiate again to get the second derivative. Now we've got a t to the n issue there. So t to the power of n, you multiply by the power, and then you reduce the power by 1. So in this case, multiply by the power, we times by minus 1. We take 1 off the power, minus 1, minus 1. Simplifying, minus 1 times 2.1 is minus 2.1. Minus 1 take away 1 is equal to minus 2. So again, make sure you're able to follow these procedures with a slightly different number there. Other than that, it will work through in the same way. So writing down the formulae for the later parts. This by t was 2.1 over t, d2s over dt squared equals minus 2.1 t to minus 2. And then moving on to section B. Now there is no section C in this case because there are no turning points on the curve. So actually we don't need the second derivative past part A, we just need the first derivative. So to find the gradient of the curve at t equals 2 and t equals 4, we need to, as usual, stick the t value into the formula for ds by the t. So the gradient equals ds by the t, which is 2.1 over t. So 2.1 divided by 2, which is 1.05. Do the same for t equals 4. So the gradient is ds by the t when the t is equals 4 is filled in. So 2.1 divided by 4 equals 0.525. Again, if you want to get merits and distinctions, you're going to have to explain your method and compare your answers to those obtained in A5. So basically, look at your two answers in A5. If they're close, they're good estimates. If they're not close, they're bad estimates. They don't have to be good estimates in order to get the marks. Remember, these are the actual ones, so it's the answers in A5 that were the estimates. So make sure that you make your comments in order to get the full marks. Then A18 on page 34 is very similar. No turning points, just another function to apply rules to. So on page 34, the examples booklet, this time the formula is 2.1 e to the 0.5t. So when you're doing e to the kt and you're trying to differentiate it, the k, the number in front of the t, goes to the front by multiplying. So ke to the kt. So ds by the t equals, well, the number in front of the t is 0.5, so that's what we multiply at the front. So 0.5 times 2.1 e to the 0.5t. Do 0.5 times 2.1. We get 1.05. We get our formula for ds by the t, our first derivative. Differentiate again. We times by the 0.5 at the front. So 0.5 times 1.05, so again it's a number in front of the t that we times at the front. So 0.5 times 1.05 is 0.525. E to the 0.5t. So those are your first and second derivatives. Again, this is quite advanced stuff, so at the very least, make sure that you can follow through the steps with different numbers. So if there was a different number other than 2.1 and a different number other than 0.5, whatever those two numbers were, you would follow the same numbers in the same places and do the calculations with the new numbers. Make sure you're at least able to do that. Now we'll need ds by the t for the next section. So I'm making a note there. So part B. We're trying to find the gradient of t equals 2 and t equals 4. So t equals 2, the gradient, as has been for last few sections, the same as ds by the t, but with the t equals 2 filled in. So we've got 1.05 e to the power of 0.5 times 2, which we can do on the calculator. So 1.05 e to the power 0.5 times 2, and two decimal places, 2.85. Do the same thing with the other t value, the t equals 4. The gradient equals ds by the t. So 1.05 e to the 0.5 times 4. So stick that into the calculator. We get 7.76. Two decimal places. Now, to get the merits and distinctions, again we're going to have to explain method and compare our answers. So these, though rounded, are the exact answers. So your answers from A6 are estimates. So basically judge your estimates based on how close they are to these true actual answers. So if your first one's really close to 2.85, it's a good estimate. If it's far away, it's not a bad estimate. And same for the 7.76 corresponding to t equals 4. Best of luck.